Okay, so we have a normal distribution problem here, and let's go ahead and try to solve it. So it says historical data show that customers who download music from a popular web service spend approximately $22 per month with a standard deviation of $4. And here's the assumption that we're dealing with a normal probability distribution. And part A is asking for the probability that a customer will spend at least $19 per month. Part B is asking for how much or more do the top 10% of customers spend. And part C is asking for the probability that a customer will spend less than $25 per month using the standard distribution function. Okay, standard normal distribution function. So let's go ahead and tackle this one at a time. We need to know the mean and the standard deviation, which is given to us in this problem. So the mean is $22 and the standard deviation is 4. And part A is asking for the probability that a customer spend at least $19 per month. Now, I did go ahead and create a normal distribution curve as well as the standard normal distribution so we can get a better understanding of what we're trying to do here. So since we are dealing with a normal probability distribution, this is how a normal probability distribution would look like. It's a bell-shaped curve, it's symmetrical. Anything underneath this curve, in total, it represents a sum of 1 or 100%. And you'll notice on the x-axis, this is the units that we're dealing with in the problem. So if the mean is $22, then that should be right down in the middle of the distribution. And that's that 22 that you see right there. I use the empirical rule to get plus or minus 3 standard deviations from the mean, and that ranges from 10 to $34 per month. So now what I want to do is go ahead and highlight what we're interested in. So if we are interested in at least $19, well, we know that the $19 is going to be right here, this area, right? And at least mean 19 or more. So if I were to just put a line all the way up to this part of the curve and highlight everything to the right of it. So everything that I have highlighted is what I'm trying to find in terms of probability. We're looking for a cumulative probability, but we're not looking for 19 and less, we're looking for 19 and more. So we're going to have to use the complement rule when we're trying to find this probability because we know that if we use a norm.dist function and use true, it's looking for 19 and everything less than that. We want 19 and everything more than that. So I'm going to start filling out the parameters that I have here. 19, since we're looking for at least 19. The mean is 22, the standard deviation is 4, and cumulative will be true. I'll go ahead and format this to 4 decimal points. There we have it. So the probability that a customer will spend at least $19 per month is about 17.34%. So that's part A. Part B is asking for how much or more do the top 10% of customers spend. Now let me go ahead and just delete this part. This is a cumulative distribution type of problem, but we're working backwards. So we're not looking for a probability, we're looking for an X value that would represent the amount of how much or more the top 10% will spend. So instead of the norm.dist, what I would do is use there's a norm.inv, looking for an X value rather than a probability. So we have 3 parameters that we need to fill out. There's a probability, and that's going to be the cumulative probability of interest. Then we have the mean that's given to us in the problem, as well as the standard deviation is also given to us in the problem. So if we're dealing with the top 10%, let's go ahead and assume that somewhere around here, I'm just going to guess, somewhere around here would represent 90% cumulative. So from this point here and everything to the left would represent a total of 90%. Now, if we're looking for the top 10%, that is the opposite of that 90% cumulative that I have highlighted. So that would be everything that I'm highlighting in yellow. So I'm going to hit the equal sign and select norm.inv. For the probability, I want to put the cumulative probability of 90% since I am looking for the top 10%, right? I'm going to put 0.90 or I can put 90 and then put a percent sign. That will work. The mean is 22. The standard deviation is 4. This is the answer that we're looking for. We're saying that the top 10% of customers spend at least $27.13. So you notice I kind of estimated, I highlighted it. I was kind of close. So I just wanted to make an adjustment if I was drawing this out. But that's the amount that we're looking for in terms of top 10%. Now for part C, it's saying find the probability that a customer will spend less than $25 per month using the standard normal distribution function. So this is what I did earlier before I started the video with some of my prep work. I want to figure out what the z-score would be for $25. And if to find a z-score, if I say equal sign standardize and I put the value 25 for x, and then the mean is 22, standard deviation is 4, I get a 0.75 z-score. You're dealing with a normal distribution like you see here on the left. When you're trying to find probabilities and we're using a norm.dist, what's going on in the back end is we're converting the x value that we're interested in. So originally we're interested in $19, at least $19. So we converted that 19 into a z-score and found the probability that way. And that's what's happening in the back end. So when we're saying here that the z-score for $25 per month is 0.75 and it's positive 0.75, all we're saying here is that the value of $25 is 0.75 standard deviations away from the mean. And we're saying away from the mean, we're saying above the mean. Now we know that the mean here is 22 in the problem, and we're looking for a probability of spending less than 25. Well, we know the value 25 is a little bit more than the mean. So we're looking for the cumulative probability of 25 and all the way down. So let's go ahead and figure that out by using the norm.s.dist. This is different from part A where we use the norm.dist. So if I were to select that function, I have two parameters. One's a z-value and the other one is a cumulative. Now, we know what the z-value is. We said it was 0.75. And I am looking for a cumulative probability because I'm interested in the value of 0.75 and everything to the left of it in terms of z-scores. In terms of x units, in the problem, we're interested in the value of 25 and everything less than that. So I'm going to hit enter, and this is my probability. Let me format this. Now let's go ahead and refer to this standard normal distribution curve that we have here. So we were interested in a 0.75 z-score. So if we're focusing on a standard normal distribution on the x-axis here, notice these are all considered to be z-scores rather than the x units in the problem. Well, we can convert each one of these into z-scores, and that's what you see here. So the value 22, in terms of a normal distribution, if we were to standardize that, it's a value of 0. The value of, let's say, for example, 20, let's say 26, 26 represents one standard deviation above the mean. So you'll see that 1 right there. Right, so these are just the standardized values of them. Now, here's 0.75 z-score, and we're looking for everything to the left of that. We're looking for that cumulative probability. And when we use norm.s.dist function, we found that to be 0.7734. Okay, so remember that any x value that you have in a probability problem, assuming that you're dealing with a normal distribution, then you can convert it into a z-score. So in part A, we were not dealing with a z-score, we were dealing with the x value of $19 per month. In part C, we were dealing with a z-score. For part A, we have this probability, and for part C, we have this probability. So they're both the same. In part A, if we were to convert the x value of $19 into a z-score, we will find it to be the same z-score value in terms of its absolute. Now let's go ahead and demonstrate this. Standardize and select the value of 19. Mean is 22. Standard deviation is 4. I get a negative 0.75. So in this case, we are looking for $19, right? This right here, or more, everything to the right. But for part C, we're looking for the probability of a z-score that's less than or equal to 0.75 and everything to the left of that. So the value of 19 is 0.75 standard deviations below the mean, and the value of $25 is 0.75 standard deviations above the mean. Hopefully this makes sense. Thank you for watching.